फिर अभी कुछ भी टेस्ट एग्जीक्यूट करने के लिए, जैसे आप डेवलपर्स हम क्या करते हैं, थोड़ा डेटा चाहिए होगा, राइट? जैसे ये वाला जो टेस्ट शीट है उसको थोड़ा डेटा चाहिए कि ये ड्रोन है, ये ड्रोन में ये पेलोड के कैपेबिलिटीज़ है, ये लेंसेज है, उसको तो अभी मैजिकली पता नहीं होगा, तो वो आपको थोड़ा देना पड़ेगा। तो फॉर दिस स्पेसिफिक टेस्ट केस आई हैव दिस एमडी5। अगेन वेरी सिंपल, कुछ है नहीं इसमें, इसमें बस डेटा है कि हमारे पास ये डेटा होता है, टिपिकली ये है, एंड ऑल दिस इज वैलिड डेटा, राइट? नाउ कमिंग बैक टू टेस्ट एग्जीक्यूशन, आपने आपका CSV लिया, आपने आपका मॉक डेटा या जो भी रियल डेटा जो DB से लाया हो, रेडिस से लाया हो, वो लिया। अब क्या करना है? कुछ नहीं, एग्जीक्यूट करना है बस, राइट? एंड एग्जीक्यूट भी मैनुअली नहीं करना है क्योंकि बहुत टाइम जाएगा आपका। तो उसके लिए हम क्या कर सकते हैं, शेल स्क्रिप्ट सुना है, बहुत पुरानी चीज़ है, बट काम करती है। तो इसमें हमने क्या किया, बेसिकली हम AI को एक टूल बना के दे रहे हैं कि भाई ये जो टूल है ये तेरे को REST API कॉल करके देगा, एंड उसमें हमने थोड़ा जो टिपिकल API में जो चीज़ें रहती है, लाइक हेडर्स रहता है, ऑथराइजेशन रहता है, ये हमने इधर ही डाल दिया है। ऑल AI नीड्स टू डू इज नाउ कि ये टूल कॉल करना है, बस इनपुट आउटपुट बदलना है, राइट? इनपुट आउटपुट कहाँ से मिल रहा है आपको? आपका जो टेस्ट शीट आया, जो CSV में दिखा रहा था, दिस इज इनपुट आउटपुट, क्या एक्सपेक्टेड है एग्जैक्ट उसको सब पता है। अभी उसके पास टूल भी है, अभी कुछ नहीं करना, मजे करो आप तो बस। तो
So the important part here is, while you are using such coding agents to generate code, right? The important part is how does the AI know the implementation part? So how does it validate कि exactly उसने जो बनाया है वो exactly validate कैसे करेगा, उसमें क्या क्या success points है, क्या क्या failure points है, right? So ये जो feedback loop है, that is very important, because let's say if you start writing code using the agent and then you start giving it the context, feedback context, अगर आप manually देते जाओगे तो you have to monitor a lot of things, right? You have to monitor, पहले तो वो test case run करो, उसका output देखो, उसके जो verdicts आए वो उसको feed करो, so a lot of to and fro, right? So that's where such frameworks और test suites come in hand, because इसमें होता क्या है कि ये जो test suite है इसका context AI को है। Now what the important part is कि जब आप डेवलप कर रहे हो, लेट्स से आपने कुछ एक चेंजेस कर दिए, कुछ फीचर डेवलप कर दिया, नाउ व्हाट यू कैन डू इज यू कैन आस्क द AI टू यूज दिस टेस्ट सूट टू रन वॉट एवर द फ्लोज दैट आर प्रेजेंट इन द फीचर, एंड जैसे ही वो टेस्ट सूट रन होता है यू गेट ऑल दोज केसेस देयर एंड उसके वर्डिक्स आते हैं। सो सेम वर्डिक्स आप AI को वही से मिल जाते हैं क्योंकि वो ऑब्वियसली आउटपुट भी मॉनिटर करते रहता है। एज सुन एज वो जो आउटपुट है वो मॉनिटर हो रहा है, now it knows the verdict of what the implementation was, right? And then obviously you can iterate on the cases and iterate on the overall flow.
So is that AI also updating your test cases CSV file?
Yes, so that's what Saurabh will now explain ki how exactly AI is using the test suite framework while evaluating.
ठीक है, तो दिस सेशन हैव स्टार्टेड फ्रेश 5 minutes ago। तो इसमें मैंने क्या इनपुट दिया, like this is the tool, the REST API tool that it will be using, it has test data जो उसको डेटा यूज़ करना है, then क्योंकि उसको थोड़ा कॉन्टेक्स्ट आना चाहिए कि मैं किसके लिए कर रहा हूँ, क्या फीचर है, तो उसके लिए मैंने रिक्वायरमेंट भी पास किया। then you have like the exact टेस्ट शीट उसको फॉलो करना है, एंड फिर ये टेस्ट एग्जीक्यूशन गाइड एंड टेक्स्ट एग्जीक्यूशन गाइड बहुत मैंने दिखाया था, बहुत क्लियर एंड क्रिस्प है, ये 3 चीज़ें ली हैं, ये करना है, राइट? दिस इज हाउ वी आर गेटिंग LLM टू बिहेव लाइक अ मोर लाइक अ प्रेडिक्टिव सिस्टम। अभी उसको एक्जैक्टली इन पता है, आउट पता है, क्या करना है पता है। इसमें चांसेस ऑफ लाइक गेटिंग लॉस्ट और खुद का कुछ दिमाग लगाना जो ये थोड़ा बहुत करता है, जो लाइक इस चीज़ में वो नहीं चाहिए। इस चीज़ में भी नीड टू यूज़ इट लाइक मोर लाइक अ एग्जीक्यूटर, तो वो सब इसमें चांसेस कम हो जाते हैं, एंड वट एवर माई एक्सपीरियंसेस लाइक कभी एरर्स नहीं होते, राइट? तो मैं भी उनको एग्जैक्ट ये पास किया मैंने, तो अभी बोला कि चल भाई ये करते हैं, तो मैं आने से पहले थोड़ा बस चला रहा था, तो उसने ये कर दिया, मैं वापस चलाता हूँ अभी, तो मेरा बैक एंड बिल्ड हो रहा है, तो 2 मिनट बस।
हाँ,
So in this you are using API to do something on a drone. So now once you run the execution, are you expecting a drone to fly or zoom out? How do you then simulate that?
Right. So first of all, we don't use real drones, like it's costly to fly and all, but of course we have simulators. Now
so these simulators are what we have built in our house, right? So these simulators actually run with the platform, and then you can actually execute the complete flow of the platform using those simulators. So simulators are the part of this test suite framework while you are running it.
if I'm getting it correctly, you want to know कि सच में वो लेंस चेंज हुआ कि नहीं हुआ, ये आपको जानना है, राइट?
वो तो होगा नहीं space. So I know that is not practical. Yeah. So what you are using that as so
Right.
you are built for all the
Yes. Also, the code is written in such a way that it can self-confirm कि lens change हुआ कि नहीं हुआ. I will not get into that, but we have like callbacks and all which monitor for like some seconds and will tell whether at least on data level it can like tell you कि मतलब change हुआ कि lens नहीं change हुआ. So that is one way of validating it. I'm getting a question, but उसके लिए आप delays introduce कर सकते हो कि like every 10 seconds you can execute one case.
this is your API testing flow testing. And real भी कैसे test करते हो? Ultimately you have to run through the real test case, right?
Right.
Ultimately ये सब तुम्हारा basic sanity. This is I will say a sanity check. Code check के sanity हो गया. And then you have to execute like the real.
This is not sanity testing. This is pure API testing.
API.
Sanity testing is what our QA guys do. This is pure developer white box code का testing, right? So
Actually जब field में test करना है using automation, then how do you do that? Because I see a similar problem. Maybe different way, but getting execution and then field में, then how do you do that?
so it depends like what you want to do. Like you want to test the dashboard, you want to test the front end. Like आपको क्या करना है तो उसके around फिर.
So you mentioned the flow, zoom in, zoom out, right? So, zoom in, zoom out है ना? ये तो actual hardware में physical होगा. ये तुमने API test कर दी, but maybe integration testing I will like to do. How do you do that with whatever you are doing?
So the important part of the integration testing and the E2A testing, right? So the first piece of this testing is the test sheet, and so the test sheet is generated using the context we have, right? So what usually the UAV team or QA team that we have do is they basically have these PRDs, these context documents, and then test cases are generated using those documents. So what we have done is certain amount of testing, right? So basic testing like API testing from the dashboard or these cases, this is basically typical what any software platform can do, right? And there are multiple frameworks around it. Now the main part is while you are actually flying the drone. So that is where the UAV team actually uses AI to leverage those test cases in the first place, because now you need to understand because there are multiple moving pieces in the software platform along with the hardware. So what the QA team does is they generate those test cases, get those validations कि exactly क्या क्या run करना है. Obviously the actual drone flying is still handled by UAV team, because obviously there are a lot of restrictions and other different moving parts.
That is still that manually, you can say, just verifying that.
Yes, but the important part is the number of test cases, because we have hardware integration, so the moving parts are different, right? And validating those require you to actually think about different edge cases, because it might happen that you were testing something and then you forgot, let's say maybe an edge case, or you weren't aware of that particular system, and while you are actually moving through different features, you might also forget those test cases, or you might not remember. So that's where the AI comes in, where you store that context and then get those cases and then run through system.
What I understand is, since you are the heavy lifting is already done, the number of edge cases that you find in the field are less.
Right. So basically this API testing ensures that we do not mess up with the actual code implementation.
Okay, coming back. So my backend is up and running. We have all the code. Now what you do is just tell it and scroll Instagram. So now nothing, it knows what to do. You can just like take one input, it knows input, output, done. And what it also does is, as SRE asked me, like it will come and store the exact output it has got, right? It will like, in the actual result column, it will like keep storing all that. So what I can do, I can come back after like, say 5-10 minutes. I can come back after 5-10 minutes and I'll just say, okay, like on a high level for this kind of inputs, I've been getting this kind of outputs and all. That's how we can like validate. So till it executes, like any questions?
One question I have now, like you're using some sort of data to actually verify what the input and output is. Now that data can become stale. Like for example, you tested something today and after 3 days that data is stale, because there might be dates, there might be something else, right? And when it is small change, and then correcting the data takes much more time, right? Is there any automation on that front to correct that data?
Right. So what you are saying is during execution or code changes, you have like the data which has like you need to like generate some new data or like clean up old data, right? Am I getting the question correctly?
So I think if you're using some data to say, okay, whether the input and output are correct or not, the agent checks that, right?
Yes.
Now, that data you generated today, I mean, if the data doesn't, I mean, the significance of data does not change over time, then it's okay. But you could be testing the system, they say, okay, make me data for the last 1 year. Now the data value will change, right?
Yes.
Put days down the
Yes.
line.
Yes.
So how
Database.
you maintain sanctity of that data in an automated way?
Yes.
Make it manually is a big task.
Yes. Thank you for pitching that, and I was going to tell that. So let me just get here. Oh, meanwhile, you can see in the background, it's like going through each and every test case. It's like executing it, and it's also writing back to the CSV. So if I can show you, like, so this is the service, like it's testing, and you can see it has like received some REST calls and it has responded. So it will like, and it's testing all the invalid scenarios. So we are getting a 400, like typically in the front new test case you will get 500 and all also. So yes, so that's the power. Getting back to your question now, if you see in the test data requirements, I have, okay, so this is like updating the CSV sheet with exact things it found. Typically you would have these in auto accept mode so that I don't have to like press enter every time, but yes. Coming back to your question, so you can see this document, right? Please don't see the credentials. So what we have is like access to our DB, what we have is like Redis connections and all. Now, in the test sheet, if you see, I have something called as setup commands, right? So if I can just go, right? In this specific test case, राइट सो इन दिस स्पेसिफिक टेस्ट केस उसको क्या करना था कि मोंगो में जो एक वैल्यू पड़ा हुआ है उसको डिलीट करना है क्योंकि उसको टेस्ट करना है. हाउ डू यू अलाउ इट टू डू इज, मैंने वो जो टेस्ट शीट दिखाया था, जो MD फाइल दिखाया था, उसमें पूरा एक्सेस है उसको, एंड इसको मैंने टेस्ट शीट में बोल भी रखा है कि अगर तेरे को वैल्यू चेंज करना है तो ये यूज़ करना है, ये यूज़ करके आपको मोंगो से बात करो, चेंज करो एंड खुद एग्जीक्यूट करो. सो दैट्स हाउ यू इंट्रोड्यूस लाइक डायनेमिक थिंग्स इन दिस. And in our software, like we are dealing with drones and all, like lot of things change so frequently. Like एक सेकंड में अभी ये था, दूसरे सेकंड में आई डोंट नो क्या स्टेट होगा, राइट. सो टिपिकली जब ऐसे टाइप का टेस्टिंग कर रहे होते हैं हम, तो वी डोंट एक्चुअली वेट फॉर ड्रोन्स टू फ्लाई एंड देन डू दिस, दैट वुड वेस्ट अ लॉट ऑफ टाइम. इंस्टेड व्हाट वी कैन डू इज, इन अ वे वी नो कि जब ड्रोन ऑफलाइन होता है तो किस स्टेट को अफेक्ट करता है. लाइक रेडिस में ये स्टेट होगा, मोंगो में ये स्टेट होगा, राइट. सो वी जस्ट आस्क इट कि भाई ड्रोन में यूज़ करेंगे अपन, तो एक्चुअल टूल यूज़ कर, वो डेटा बदल देगा. So that's how we can like introduce dynamic things in this. Yes.
I have a two-part question.
Yes.
Firstly, the second phase of all of this, where you are running this test suite, what advantage is LLM giving over any kind of deterministic framework? Because I understand LLM writing the CSV or in some format, that is all context driven based on what you are looking, but running all of this, what exactly is the LLM advantage versus if there is even a possibility of that system being probabilistic which will cause issues, rather this is all deterministic stuff it is doing, right? So LLM is it speed that is giving you the cloud?
So the real ROI in all this is not in execution, it's about how you generate this like test, the CSV sheet I showed you. This is the ROI, and you generate it in a way that any like your AI tool can execute it, right? AI, we as well know, without data it will get hallucinated, it will get lost and all. So how do you ground your AI? So the real thing what I believe in this is like getting to this sheet which it can like read, do the data manipulations, has clear instructions. So that's where you get the real ROI. It's not in execution. In execution, there is slight thing that you get when you're using AI is you can have the capability to like do Mongo operations or Redis operations and all that, which typically standard tools either you have to configure or like write some scripts and all. So yes, the real thing is in getting into this CSV sheet using all the context you have, And for that, you need to do 10 different things before getting to the test sheet. Is like you have your standard development for documents, because as I said, the controllers and all, they don't change. Like 90% is same thing. So it's important that we follow all those standards and all. So the real ROI is in getting to this test sheet. Execution is, yes, I agree, it's nothing.
Secondly, like this entire
I'll just
exercise
stop it.
of like making this CSV and the generating meta of that CSV is correct, but rather than this form, I like why not just have all of this as part of unit test? Because anyway, beyond that code, there is the scope से वो code है, तो anyway Redis, Mongo, everything else is getting mocked with realistic data, but essentially could be expired or could be different as well. That doesn't matter to this API.
Yes.
So why not just have this as part of like a just unit test framework or something like that? If like that is more maintainable, right? In my opinion.
So we are never saying that you don't have to write unit test. Unit test has to be there, so that next time you change the code, you can run the suit fast. But typically API developers, like backend developers, of course they don't just release the system with the unit testing, right? You have to go and test some scenarios with the realistic API testing. Like some people said they use Postman and all. So
That is where my question is: how is this different than the outcome that this is generating? How is this different than unit test?
So first of all, I'm interacting with the real system. Instead, I'm not mocking and all. I'm interacting with the real controller, real data, real input, real output. So I think that's where the ROI comes in here.
So maybe a reverse question for you to think also could be that if unit testing was enough, then why to even have a tool like Postman? So what is the use of Postman if unit testing was indeed enough for a backend developer? So clearly unit testing will effectively just it will mock a lot of different scenarios. It will just focus on few functions that you have implemented, but it won't do a thorough integration testing wherein multiple functions gets called in a certain workflow. When you hit a controller, then how the controller will call multiple different services. It will interact with probably other services, other microservices as well. So all of that testing usually is not covered under unit testing, and that's why we do Postman testing, so that we hit an API and see how it responds.
My question is different. My question is not why you don't need not the testing buckets, but kind of what is being done here can be integrated very well into the unit testing framework that we already do, or probably a lot of people might be doing. That will give better control in terms of output, reporting, etc. Because what is being done here is you are just mocking on different levels, right? Okay, I'll mock on the service out level, yeah. Service dependencies.
It's not mocking. It's not actually mocking. We are dealing with real like services which are running with we have real simulator. So I'm mocking very little. So in unit test, if I have to write a unit test here, I have to mock the external service that it's using, whatever it's calling. I have to mock a simulator and all. Here I don't need to do all that. I'm reusing it like existing systems. So saves a lot of time to me. And I am very.
It definitely works really well with CSV. CSV got definitely.
Yes. So as you can see, like it executed and it like keeps updating the test sheet. You can come back and just see, okay, this is the in, this is out, and yes, I'm fine with the API. We can go ahead. Now this pattern you can apply to any new route, any new REST API you are writing. It's very scalable, and like you guys can integrate it in your workflow. Takes nothing special. It's just a few documentation files and basic input about what the feature is and all. So yeah. Now Shreya will continue. This is about standard REST endpoints. Like 90% of you guys must be dealing with REST endpoints, but at Fightbase we deal with a couple of other things as well, not just standard REST. So Shreya will get into that. And it's very interesting. Have a look. He's written like okay, you should just see it and enjoy.
So any other questions before we start the next session?
Right. So what we saw was a typical API CRUD-based operation testing, right? Now what we are moving into is, so Flightbase, has been leader in automated drone operations from quite a few, like for past few like years, and now the problem of automated operations is quite solved, right? You can simply basically fly drones using remote operations, right? And the true game starts now, because now what we are thinking is, we are thinking for autonomous operations, right? So automated operation is more like there are standard flows present in the complete picture, and you can simply fly the drone. But autonomy truly brings that edge intelligence, right? Because now what you can do is, you can use those automated operations to actually use the on-site intelligence to maybe respond to certain actions, maybe perform different flows while you are operating. So all of this is now captured using the Flightbase AIR. So Flightbase AIR is basically one of our products. So Flightbase AIR. So before we move to the product, you guys must have used a lot of AI tools and inference services, right? There are a lot of different detection models, there are a lot of different, and now because of foundational models, we also have VLMs, we have different models as well, right? And you must have seen that a lot of these models, they are provided using some cloud services, and with cloud services there are few limitations, right? Because when you deal with real-time data, what you need is, you need real-time inference, and because you need real-time inference, you might not actually use cloud service because there are latencies, or there are environments that have low bandwidth, or low bandwidth basically. So to tackle that problem, Flightbase had introduced a solution called AIR. So basically AIR is a edge device. So it's a physical edge device which is deployed on the customer side. It is connected to the docking station. So the docking station that we have right here, right? So there is one AIR device, edge device, that is connected to the docking station, and what this device does is, this device brings that real-time inference, detection and response suite to the automated drone operation system. So now you have autonomous drone operation system. This particular system provides all that real-time detection, response, and you can also, and then the real-time alerts on those particular operations. So the current functioning of this particular system is what, so a very basic thing, which is person detection, vehicle detection, right? It's a very basic thing. But then when you deal with real-time data, right, you deal with real-time video streams of the drone, that's where the magic happens. So right, so this particular device, right, so it has this inference engine. Now what I have shown a diagram here. So basically this is typically a very high level diagram of what we do in the detection cycle, right? We have a lot of moving parts. We have the live video stream coming from the drone. We have the AI models which are basically used using the Triton server. So you guys must be knowing NVIDIA DeepStream framework, right? If you guys read, so basically this particular AI inference engine, what it does is, you can load different models into the inference engine, and then you can apply those, use that inference engine to actually get those detections, bounding boxes around the detections. So what this particular diagram does is, it starts with all those data points. You have AI models, you have video stream, so live drone video stream, you have certain other different metadata that is being used in the service. And then once you start getting that data, what it does is, it passes it to the inference engine, it gets those data and then pushes it out to the actual output, so that the detections and everything can be seen on the complete dashboard. Now, because there are so many moving parts, right, there are different components present here, and this is not something that we see on regular basis for and something that can be tested very easily, because I cannot simply go and maybe create a REST API call and do everything, because, and obviously I need to also test with some real-time data. I just cannot mock every time. So to cater that problem, what we came up with is, we basically have a test suite present in the code base itself. So I'm not going to go very deep in the code, but
Zoom करना.
It's okay, continue.
Zoom कर.
right. So in the repo itself, we have a test suite present, and so what we have been doing is we have been experimenting how we can apply this test suite for each and every moving part in that complete picture. And what we have is a test framework present in the repo itself. Now this test framework, as Saurabh explained, so it follows a similar pattern what Saurabh did, but on something different line. So what we have is a complete test framework here. So we have documentation around how this test framework works, what are the different moving parts in that particular pipeline, right? And then we also have these different sections. So as I said earlier, mocking every data point in this complete pipeline will not help me to actually test the complete pipeline, because this is not some standard flow, right? There are different elements included in that. So what this does is it has all the documentation around what are the moving parts. So the moving parts that we saw was video stream, we saw Redis, then we saw other different AI models and the other stuff. Now what I can do is, so because this test suite has all the cases, so it has cases around, very basic cases around whether the video stream is available or not, whether the video stream maybe suddenly drops away, suddenly maybe the inference is not available there, and so a lot of different cases. And simply as Saurabh said, we can generate those test cases using AI. Like we can get a PRD, we can get a documentation and generate those test cases. Now what we are going to do is, so I'm going to ask the Claude Code to, so I have already given a prompt here to actually run those test cases. So it basically read the documentation and then it has asked me to execute the test case. Now because this particular setup is running on some remote device, which is the AIR, it has access to the AIR, the remote device, and now basically we are going to execute it. Right. So it has started with the execution cycle. So just to show how real time data is being tested. Okay, it's starting. We'll wait for like few seconds. Right. So right. So what it did was, it had a sample video present in the suite itself. What it did was, because it now has the test framework access, what it did was it basically ran the test suite. It passed the video feed that we have there, and then it so it is running those cases. So basically it ran those tests which are mentioned in the test suite. Then while it was running it, it also captures the, so now we did one-way pipeline, right? We actually ran the test suite. We have that capability. But now the real ROI is basically if we can leverage that feedback. So what I can do is I can simply ask Claude to actually monitor, because this particular process is running. What I can do is I can actually ask Claude Code to check the verdict or output of that particular service that is running. So what I can do is maybe I can ask here, so what it will do is it will basically now check the output of the service itself. So it is now running, it has context of, okay, I'm running these particular test cases. Now it also has the context of, okay, I'll check the output of the service itself. So it is actually checking the real data that is being passed in the to the service. So Right. So it asked me to actually check the logs. So it is checking the logs now. Now this is where the pair programming mode comes into picture, because now the iteration cycle is very fast. So what you can do is you can basically ask Claude, any coding agent, to actually access the logs. It is checking those logs in real time. It also has the access to the test suite that we have. And let's say if you are even making a single line change, and now because you have, let's say you have a large amount of code base with you, now the iteration is very fast, because let's say if you edit that particular line, you can ask Claude to actually execute that complete test suite. You can ask to actually check the logs for that particular feature, and let's say even the complete service, and then you have those verdicts, and then you can actually brainstorm, okay, if let's say something goes wrong, how do I fix it? What are the ideas to fix it? Because it has context to the service, it has context to the logs, actual logs, and not manipulated or mock data. It has access to the test suite as well. So the cycle becomes so fast that you can edit those changes, and let's say after editing you might think, okay, let's edit the test suite as well. Let's add an extra case to maybe catch something else. You can ask the agent to again edit the test suite, because it has context to everything. You can ask the agent to edit the test suite and then again run it. So this is how the whole loop continues until you have a very good quality generated code, as well as the entire cycle runs fast. So this is a very basic framework that we have come up with, but so this is an idea, right? But what we can do is there are different angles to it. So we have been hearing a lot about agents, right? AI agents, agentic flow, right? And there have been a lot of no-code agentic tools as well. So this particular framework can be implemented on such agentic flows and then used like anywhere. Like you can have this whole suite as an MCP server, so that the Claude has access to those tools for those for running those test cases. It has access to that content to running those cases, or you can simply have some agentic flow to actually run this whole loop. So this whole loop actually brings that the real magic of the AI agents. Yeah, so that's it. It will now, I think the test cases might have been completed. It will check for logs, and then probably like we can brainstorm further on how, if there are any issues or not. So yeah, any questions?
How much of data is process required on your AI server, and how much of it can be done offline?
So you're asking about while running the test suite, or while like actually running the service?
Actually running the service.
So for currently the service has access to its own device GPU, which actually runs the inference engine and stuff, and rest of the basically logic is run on CPU. And basically while running this test suite, it is actually running those services and actually giving that data point. So as we saw that the video stream, right? So it is actually passing that video stream, which is being passed to the service, which uses that GPU to actually get those outputs.
It looks good. Like I also use it like during development. It helps like if it has an access to actual services that are running and it's making changes. But what I can see here is like if you have like a module and 100 test cases, and if it's running, like how do you see the let's say you are in a max plan of Cloud Code, still how do you see the context usage? Because like if you are running like 100 test cases and only one is going to fail, like, and he's still going to monitor other logs for those 99 test cases. So like, are you facing the context exhaustion? Because recently we started facing a lot of context exhaustion even with MCP servers, so we had to cut down on MCP servers which are not relevant for that section. So, and if you are doing this during development, so like within a 10 lines of code, it's going to exhaust with one session window. So how do you see that going ahead? Because if you want to scale this across all these stacks, well,
Right. So the exact problem that you said, right? So I have been facing that problem in terms of, let's say, if you run that particular test suite now, and it is trying to read that particular service as well, right? The logs. So definitely it will lead to context exhaustion. So what I've been trying to explore is how such execution cycles can be offloaded, because anyway the Claude has to just trigger that particular pipeline and maybe just monitor the logs. It won't necessarily have to store the context of what it is running and how it is running. It can, like, that can be offloaded to a different process, right? So I think that's where we can explore. I have not completely explored the options we can have there, but yeah, definitely that is one of the big problems that comes when running such test suites or running such flows.
Have you tried using Claude sub-agents so that the context window does not get over?
Right.
Have you tried that?
So yeah, so I did try the sub agents. Now the problem with sub agents is the context that we store, right? So for sub agents, there is basically an MD file where the description of that sub agent is stored, and so obviously when we run sub agents, the context is completely different. It's independent. So even there, because the number of cases are more, at times it exceeds that particular context window. So we might have to like explore other options.
So like one framework that helped me with this was to actually think if an agent has to look at that log continuously for 10 minutes while this is running, I would get bored and so would that agent. So rather having more automation in that framework, where if some test case fails, I probably take the last 1000 lines of logs, you store it in a dump for agent to analyze later, do that for every test case that fails, along with, let's say, CPU metric, GPU metric, so on, and whatever agent would normally need to debug that issue. And have that as a dump. Finally, after 10 minutes, okay, here is your dump to analyze. After, okay, 100 test cases ran, 4 failed, 96 passed. This is your dump to analyze for a test. So those kind of automations in the runner itself, like that is like kind of similar what I was asking Saurabh also previously, that having agents do the running part and kind of aggregation of logs is very context heavy and kind of inefficient, because you don't need agents power for it. Normal systems are good enough to do that. Lot of power is in it generating what needs to be in these test cases and actually getting enough dump out of it to analyze later and fix and retrigger.
Right, definitely.
Yeah, those would be like approaches you could go.
Yes, definitely.
If you can go a little bit more deeper into how you developed the testing framework, the mental model that went into, then yeah, that would be great. I'm a bit unclear.
Right. So the process of generating this test suite is basically context driven. So we basically at the initial start of building the test suite, we have a documentation on how, like, what is the purpose of that particular service. So similarly for this particular service, we have the documentation on what exactly the service is going to do, and similarly for other services as well. Once you have this documentation, you now understand what are the moving parts, what are the architecture decisions that we take. This includes the overall picture of the service. Now you need to also have a documentation on the API spec or the different API contracts that are possible in that particular service, because that's how the AI agent, or let's say any tool, is going to understand what are those calls, right? So these two documents will help build the test suite. So
But how do you create these documents? How do you create these documents to begin with, and how do you ensure that this is actually in sync with your code? Like if you keep updating your code, how do you ensure that this document is also in sync with your code?
right. So the major chunk of this particular context is the actual service documentation, right? Because that's what that's what tells what are the different pieces. So updating, so initial version of the document is the initial architecture diagram, and then while you are actually maybe implementing, if you kind of change, let's say, the architecture or change the API contract, because these agents also have context to those documents, you can like simply ask the agent to update those documents. So there are multiple options for it. So what you can do is you can simply have a hook in the Claude code to actually get triggered. So these hooks can be triggered whenever you ask Cloud Code to trigger it, and then those hooks can update certain files, whatever the description that you save for it. So that's what I tried.
Another way to do is like go reverse. You first update the documentation, you brainstorm with it, then you make the code changes. So that way both always stay in sync. Yeah, that's what I do generally.
So yeah, so then we have like this is the base documentation. Then we have the documentation for the test framework. So this documentation highlights what all parts are to be included in the test framework itself. So like there is a orchestrator, right? So the orchestrator basically runs the complete test suite. It runs the actual ingestion of video stream, the connection with the external elements like Redis or different parts in the complete services. And once the orchestrator is ready, we also have the different test cases. So here, because we don't want to mock every data point, right? We want to actually ingest real data. So there are simulators for those elements as well. So similarly, so for ingesting that video, we have this stream simulator which actually ingests the real video feed into those service. We also have, let's say, a Redis manager which actually connects with Redis and monitors and updates that data point. So one question that came, right, ki how we can actually update or maybe update the data points that we have in real time, or maybe so to solve that problem, this particular Redis manager is present, which will based on what documentation you have, it can update that data in real time. So once the data is updated, so this is what the simulators do. Now you have tests. So tests include basic test, infrastructure, and so these are all generated again using the documentation and the context that we have. Now this particular documentation, right? So this documentation also has context of what sort of parameters the orchestrator needs. Then it also has context of what type of tests are present. And finally, the context of what are the verdicts it has to monitor, because we'll have to provide, let's say, maybe when let's say the stream goes away, you have to monitor that this particular log might be visible in the service, so it has to monitor that. So all this particular context is then written down in these documents. Right. So here we have the tests, and then we have the orchestrator. So once you have the orchestrator, once you have the tests that you have to run, you can basically ask the orchestrator to run those tests and then generate the output and verdict.
Just a follow up on that. So one problem that I have faced previously is that while I am generating the code, many times I forget to ask it to update the documentation in certain intervals. So what happens is after a significant time when I ask it to update the documentation, it misunderstands the code that's written sometimes. And what I see here, it's a very probabilistic system. Like it depends on the documentation needs to be sacrosanct for it to work very like accurately. So are there any good practices or like ways in which you have identified that we can counter this and not just depend on human to remember that, yeah, please update the documentation, please update the documentation.
So yes, we have 2 minutes.
Yeah. So one way that I personally do is, so basically we use version control systems, right? So version control systems basically monitor those commits and monitor those changes that we do. So because we have a base document and we have those commits which have those changes, what I personally do is I basically so Cloud Code has access to different tools and MCPs. So one of the MCPs, so it also has access to the shell commands, right? So what I personally do is while I'm working on, let's say, different changes, I ask Cloud Code to actually run those shell commands and access those commits and check the change logs, changes that are present in those let's say the commits that we have pushed out. So what I've personally seen is now it has the Cloud Code has context to, let's say, the second last commit. It has also context to the like not exact file context, because it obviously first checks what files were changed. It has context to the second last commit in terms of what files were changed, then to the last commit, and then it checks the differences. It also has the context of the documentation. Then similar, that's how I personally update the document, because that is very efficient in terms of now it understands what files were changed and what context was changed.
Any last question? You can take it. Okay, we're done.
Thank you, Saurabh and Shreyas. So it was a very energetic session. Thank you, guys. I saw a lot of different workflows, which in fact even I don't use on a daily basis. So I also need to probably learn a bit more from you guys on how have you guys cracked certain setups. But yes, few points that Amok mentioned also make sense. So probably let's reconvene again right now after a short break. Few of us together and discuss more on how we can actually take this framework all across all of the field. Right. Thank you, everyone. And so that concludes today's session. But please stick around if you have any questions. If you want to ask Saurabh and Shreyas. We are planning to continue these DevX sessions for next few Saturdays. So next Saturday we are planning to talk about our experience.